In this video, training on the operation of the alpha-beta probe attached to an RDS base unit will be provided. The alpha-beta probe is used for detecting alpha and beta radiation. There are two scintillators used for the detection of radiation in this probe. A zinc sulfide scintillator, which is used for detecting alpha particles, and a thin plastic scintillator, which is used for detecting beta radiation. A protective cover is provided for additional protection of the mylar window when not in operational use. For operational use, slide cover off of the front of the probe. The alpha-beta probe is powered by the base unit and detects and measures alpha and beta radiation. It weighs just under 2 pounds. The alpha energy response is 3 MeV to 8 MeV, and the beta energy response is 100 keV to 5 MeV. To place the alpha-beta probe in operation, power on the base unit. Remove the probe connector protective cap from the base unit and connect the column probe cable connector to the probe connector on the base unit, inserting the cable connector until you hear an audible click. Then, with the other end, you'll attach it to the alpha-beta probe. First, remove the protective cap, then insert the connector, aligning the red dots until an audible click is heard. Now that the probe is connected to the base unit, check that the base unit home screen displays the alpha channel of the alpha-beta probe and the beta channel. There will also be an alpha-beta probe icon on the footer bar. Also verify that the correct units of measurement are displaying according to your mission or survey requirements. You can view the base unit radiation reading panel by pressing the Enter key. While on the home screen, press the back key to display the alarm thresholds. This screen will only display for 5 seconds and then will return to the home screen. If you need to change the alarm thresholds to match your specific mission settings, go to the main menu, select Probe, then select Alpha Beta, and then Advanced. The thresholds can be set for each channel, the Alpha and the Beta channels. More on this later when we cover settings. Occasionally, the alpha-beta probe's mylar window can get damaged and cause a light leak. A light leak is manifested by an abnormal increase in either the alpha or beta readings when the probe is in operation. So let's do a light leak check. Turn the face of the alpha-beta probe towards a source of light like overhead lights or a window. If there is a light leak, the alpha or beta counts will increase significantly. Observe the radiation reading on this screen and note the readings if they have increased dramatically or not. If you see increased count rates for alpha or beta channel, verify that the increased count rates are due to a light leak by covering the face of the probe with the probe cover or another opaque material such as cardboard, a jacket, or a piece of paper. Leave it in place for 5 minutes, then observe the readings. If the increase in counts is caused by a light leak, the elevated reading you saw when facing the light source will lower slowly. If you remove the opaque material and turn the probe face towards a light source again, those counts should increase. If a light leak is present, the alpha and beta count rates will rise abnormally high again. If you determine there is a light leak, follow the troubleshooting steps in the manual based on your observations. If you have access to an alpha check source, perform the alpha source check as described in the manual. For the purposes of this video, I will only be demonstrating a beta source check. The method for doing source checks for both alpha and beta detection is very similar. Perform a beta source check by following these steps. First, press the home key. Locate the cesium-137 check source that came with your system. Ensure that it is less than 30 years old. Place the check source with a label away from the face of the detector and in direct contact with the alpha-beta probe protective grate in the center. Acknowledge alarms as applicable by pressing the Enter key for each alarm. Then press the Menu key. The data icon will already be highlighted when accessing the menu. Press Enter to select it. Press the down arrow key to highlight log settings and press Enter. Use the right arrow key to highlight the scalar data log mode, then press the down arrow key to highlight the Advanced button and press the Enter key. If the duration is not set at 30 seconds, press the Enter key to set the scalar duration. Use the data entry screen to set duration to 30 seconds, and do that by highlighting the 3 using the arrow keys and then pressing Enter. Highlight the 0 and then press Enter. Then highlight the Done button and press Enter. Press the Home power key to return to the home screen. Press the left arrow key to start the scalar count and continue to hold the check source in place for the duration of the scalar reading, which is a countdown of the 30-second duration. Note the number of counts reported in the beta radiation reading panel at the end of the 30-second count. Verify the radiation reading value falls within the range of 13 to 95 kilocounts. At the end of the scalar duration, the radiation reading will not change. The base unit will continue to monitor for radiation in the background. If you want to see active radiation readings again, you must change the data log mode back to auto threshold or auto interval. Let's go ahead and change the settings back to auto threshold data log mode. Press the menu key. The data icon will already be selected. Press the Enter key. Highlight the log settings icon, pressing the down arrow key. Press the Enter key. Use the arrow keys to select Auto Threshold Data Log Mode, indicated by the black circle above the words Auto Threshold. Then press the Home key to return to the home screen. To continue with the beta source check, press the menu key on the base unit, highlight the health icon, and press Enter. Highlight the Rad Test button using the arrow keys and press Enter. Leave the alpha-beta probe in direct contact with the check source for 1 minute. Verify that the probe beta count value displays at least 1 count or higher and displays pass. At the end of the minute, press the Enter key to acknowledge the results of the test. Perform troubleshooting as found in the manual if the beta detector counts remain at 0 for more than 1 minute or the test does not display pass. The alpha-beta probe is used to monitor for alpha and beta radiation. Both alpha and beta radiation have a very short range in air. Alpha and beta radiation monitoring must be performed with the front face of the probe in close proximity to the area being monitored for contamination. To operate the probe, hold the alpha-beta probe by the handle. Hold the probe close to the suspected contaminated surface by moving the probe at a pace determined by your standard operating procedures. If the alpha channel counts are higher than 90 counts per minute, the beta channel counts are not accurate. To take an accurate beta measurement in such circumstances, place a piece of paper between the alpha-beta probe and the contaminated surface. Do not let the probe face come in contact with what is being surveyed, as this could lead to puncture of the mylar window or contamination of the probe face. There is a metal grate and then a protective mesh screen in place to protect the mylar window. This window is very thin and can be damaged easily if the probe is not handled with care. We will now cover menu items related to the alpha-beta probe. First, let's go over how to change what radiation readings are displayed in the left and right radiation reading panels of the home screen. Press the menu key, use the arrow keys to highlight settings, then press the enter key to select it. Use the arrow keys to highlight the advanced button and press enter. You can choose what radiation readings to display in the left and right panel on this screen. Use the arrow keys to change panel options. Then press the home key to view the changes made. To view the health details of the alpha-beta probe, press the menu key, use the arrow keys to highlight health, and press the enter key to select. Use the arrow keys to highlight details for alpha-beta probe, and press the enter key to select and view alpha-beta probe health details, which will include system notifications and warnings. To view the alpha-beta probe information, press the menu key, use the arrow keys to highlight the info icon, and press enter. Use the arrow keys to highlight the alpha-beta icon and press the enter key to select. From the info menu, you can view the serial number of the probe, firmware version, printed circuit board version, and calibration information. To change the radiation measurement units for the alpha-beta probe, press the menu key. Use the arrow keys to highlight probes, then press enter. Use the arrow keys to highlight the alpha-beta icon and press the enter key to select. Use the arrow keys to change between the alpha channel and the beta channel. Use the arrow keys to highlight the advanced icon and press the enter key. From the probe menu, you can control the units of measure and alarm thresholds. To change alarm thresholds, press the down arrow key to highlight the alarm threshold value you want to change. Then press enter to select that value. You will see the data entry screen appear. The previously set value is displayed above the number field. Use the arrow keys to highlight a number and press the enter key to enter that value. When finished entering the new threshold value, use the arrow keys to highlight done and press the enter key. Press the home key to return to the home screen. Before beginning Mylar window and/or protective screen replacement, make sure the alpha-beta probe is disconnected from the base unit to prevent damage to the PMT, which is the detector inside the probe. Wait for at least 1 minute after disconnecting the common probe cable. Failure to comply may result in damage to the equipment. Full detection capability for the alpha-beta probe will not be ready until the scintillator that sits below the Mylar window has settled for 2 hours after exposure to light. Failure to comply may result in inaccurate readings. Replacement of the Mylar window can be done in dark conditions to try to limit light exposure. However, if the Mylar window was damaged, the scintillator will likely have already been saturated with light and will still need 2 hours to settle. After replacement and completing source checks, you should increase background monitoring frequency for up to 12 hours, while background levels gradually decay as the light saturation of the alpha-beta probe scintillator slowly dissipates. To replace the Mylar window and protective screen, face the probe up, loosen the captive screw, and open the hinged protective grate. The Mylar window is prefabricated into a one-piece part and should be easily removed and replaced as one piece. It blocks ambient light from reaching the scintillator. When damaged with even a small pinhole, light leaks occur and cause inaccurate readings by the scintillator. Remove the protective screen. Then remove the Mylar window. Inspect the protective screen, discard and replace it if it is damaged. Inspect the Mylar window, discard it and replace it if it is damaged. This white part is the scintillator that absorbs light and is what detects radiation. Install the Mylar window into the Mylar window well to cover the scintillator with the black frame towards the probe. Install the protective screen on top of the Mylar window with the padded sides toward the Mylar window. The Mylar window and protective screen can shift when closing the protective grate and cause a light leak if not placed correctly. To place it correctly, close the hinged protective grate and apply pressure on the edge of the protective screen and Mylar window to hold in place while closing the protective grate. Ensure that the captive screw engages with the threads in the hole in the probe and tighten. Hand tighten only. Do not over-tighten the captive screw. Install the alpha beta probe protective cover by sliding it on the front of the probe. Allow the probe at least 2 hours to dark adapt, which means the scintillator needs to take time to settle after being exposed to light, even from light leaks from very small holes, prior to plugging it into the base unit and powering it on. The probe must pass a source check before being returned to service. Connect the probe to the base unit. If the radiation reading panels show normal expected background counts for alpha and beta channels, the Mylar window replacement is complete. Complete a source check before returning the alpha beta probe to operational use. In summary, this video provided basic instructions for the use of the alpha beta probe. Additional instructions can be found in the RDS technical manual.